let's bring out our TIs. We're going to look at solving the equation and its related inequalities graphically. My favorite part. So this means we're going to use our TI. And we've done this before with chapter 1 and chapter 2. All that changes really, it's not really the steps, it's just the equations and the inequalities that we see. So now in chapter 3, what we're looking at is we are addressing solutions to quadratic equation and quadratic inequalities. So when I do this, I really prefer using the root 0 method. I told you as long as the equation, when they start getting a little more complicated, it's very, I think it's suggested that you move everything to one side with 0 on the other, because then all you have to do is scan the x-axis for your roots and zeros, as opposed to looking for intersections everywhere. But feel free, play along. You can always try it out with the intersection method, see what works for you. But before I start everything, if I am using the root 0 method, I do have to move everything on one side so that I can compare the quadratic equation to 0, or quadratic expression to 0. So it's a lot nicer to try to move a constant over. So all I'm doing for each of these is subtracting 5 from the right-hand side so that I can get my quadratic equations and inequalities in standard form. So I have x squared plus x minus 5 equals 0. X squared plus x minus 5 is less than or equal to 0. And I might relabel them just so that I'm clear. And I have x squared plus x minus 5 is greater than or equal to 0. Make that 0 a little nicer. So that's pretty much as much math as you need. You'll notice if you try to solve this by hand, you don't really have a nice factorable trinomial. And that's done on purpose because that's kind of showing how cool the TI can solve these without needing to know how to factor or anything like this. So now that I have this, what I'm going to do is look at solving the related equation first. And that's always the case when we go through these. So first step, pretty much what we're trying to do is we're finding the zeros, or our roots if you want to call. So we have to find the zeros first. And how we do this is we're going to pull up our TI and enter this in our function editor. So let's do that. Okay, so remember, we should have, if we press the y equals button, I guess it was already there. I'll just show you again. I press the y equal to pull up the function editor. I do have x squared plus x minus 5. I'll double check one more time just to make sure. X squared plus x minus 5. Okay. So now that that's graphed, we'll press the graph key. And we see we have a parabola facing upwards. And our main concern is figuring out, so let's go back, excuse me. Where does your parabola cross the x-axis? Hence, that's why we're using the root 0 method, because we're looking for the roots. So notice it doesn't cross that very nice point, so we really have to focus on using our TI to help us find them. So in both cases, our favorite keys, one more time, is second trace. And what we're looking for are the zeros. So that's item number 2. And we do have to move. Sometimes this goes a little faster. Let me try one more time. Get the graph there. It's a little nicer when you have the handheld calculator because it doesn't accidentally press keys, but I digress. I'm going to trace again. I'm choosing the 0. That's item number 2. And there we go. I see the screen that I want to see. We're looking for the left bound. So if I'm going to find the root that's on the left, I'm going to move the arrow key to help me see a left bound. So you've probably had a lot of practice with this already. Left bound, we'll press enter. Then we'll move it a little bit over so that we have a right bound. just so that we are isolating where that 0 would be. We press enter one more time, we make the calculator guess, and we do have one of our roots. And notice it's not a very nice integer or anything. So what I'll do for myself is I will take about a 4 decimal place approximation whenever I'm unsure. Maybe directions might specify otherwise, but 4 decimal places is pretty safe. So I'll write that down so I can come back to it when I make my sketch. We'll do this one more time. Second trace, one more time. Press item number 2, 0. And we're going to move the cursor using the arrow keys so that we have a left bound. There we have our left bound. Press enter. Move your cursor so that you have a right bound. Press enter. And now you have isolated where your 0 would be. Make the TI guess, so press enter one more time. And what we do have at this point is our other 0. So that's 1.7913. I'll take a decimal place rounding, 4 decimal places. So this is really all we need. What I like to do when I'm showing work, if I've solved something graphically, I will immediately sketch the graph on my paper. So I will do that. We're going to go back to our work. And this graph, because you can use it to solve all 3, sometimes I might just put it in the middle. And so I kind of remember when I graphed it, it looks like I had a negative root and a positive root. So I'll just kind of make sure, I'll do the best I can to make sure that that is showing in some sense. So I have a nice little sketch of Y1. And again, the goal for part A was to figure out what those roots were, and we did. If you remember, one of them was negative 2.7913. So that's what we're breaking up the x-axis into 3 different regions. So I'll write one of the solutions. And so we're just finding the roots, so that would be used with braces. Negative 2.7913. And then the other root was 1.793 when we rounded. So I always like to sketch my roots so I know that the x-axis is broken up here into 3 different regions. And then I'll write my other solution, 7913. So part A is solved. Now, as you've probably already done many times in chapter 1 and chapter 2, that's the roughest part in terms of using the TI. The next difficult part would be to interpret the graph that we have drawn for ourselves and see which regions is part B addressing and what region is part C addressing. So remember that the boundary points, or the zeros, are breaking the x-axis up into 3 different regions. The region before negative 2.7913, the region in between negative 2.7913, 1.7913, and the region after 1.7913. So 3 different regions to consider. We will kind of recycle our idea of trying to understand when your inequality or your quadratic expression is compared to 0 with an inequality symbol, you just kind of have to interpret what does that mean. Less than or equal to 0 is kind of another way to interpret where do we have negative y values. Somewhat like the sign analysis in a way. So if we're trying to understand where do we have negative y values, we can use the graph to help us interpret. You could kind of test, but you have enough experience with parabolas by now that you're saying, well, if I were to test it maybe over in the middle, I noticed that my corresponding y value, I'd have to go down to find it. So I have corresponding negative y values for all x values that are in between those 2 zeros. So if I'm going to write the solution on that for part B, I would write this in probably interval notation. It's usually the fastest way. I would address all the numbers in between negative 2.7913 and 1.7913. And then being extra careful whether I use parentheses or brackets. Because I have the or equal to, that is indicating that we are using brackets to enclose our boundary points. So here we have part B, solution. And then no extra work needed. Part B and part C are related in the fact that they're in a way they're opposites of each other. Just to kind of point this out one more time, when you are interpreting the quadratic expression in relation to 0, you're kind of reading it out as greater than or equal to 0. I'll write 0 a little nicer for you. A little nicer, we'll see. And so when you talk about greater than or equal to 0, you're trying to ask yourself, where do we have the positive y values? And if we're going to look at that a little more carefully, the positive y values have to be where there's not negative y values. So it should be the two branches, the two edges of your x-axis. And if you're not sure, you can make a test value, draw a test point, and you notice that you have to travel upwards in order to hit your graph. Hence, that's why you have a positive y value. Both cases, by the way. So if we're going to address this for our solution, for part C, we're going to describe the region before the negative 2.7913. So we're going to go from negative infinity to negative 2.7913. I'm going to use a bracket based on the greater than or equal to. We write union, start up again at 1.7913, all the way out to infinity. And now you have another technique on how to solve quadratic equations and related inequalities graphically. So hope this helps out. See you in the next section.